Hi, my name is Christina Martine and I will be your host again today for another mathematics video brought to you by RJ. So today I have a puzzle for you. Is it possible for three equidistant points to lie on a straight line? First, let's define equidistant. So equidistant literally means the same distance. So let me be clear that when I say every point has to be the same distance, every point has to be the same distance as every other point. So to better visualize this, let's draw a horizontal line. So we need three equidistant points on the line. Let's start with 1 point. And now we need a second point. And to get the third point, we need to make a circle around our first point with the same radius as the distance that we've chosen. So in this case, I've chosen 3 inches. So I'm just gonna go ahead and do that now to the best of my ability. I don't have a compass, so I'm just gonna cheat a little bit and measure it out so my circle is almost close to perfect. So to get the third point, we need to do the same thing, draw another circle with our second point. So now I'm going to erase the circles and label these from A to D. So we can see now that a third equidistant point can be placed on this line. Can it be placed here or here? Let's figure that out. I placed a question mark above A and D because we need to check whether each possibility is actually equidistant. So let's start with A. Even though the distance between A to B is equidistant to the distance from B to C, it is not equidistant to the distance from A to C. Therefore, we cannot place a point at A. So we're gonna scratch that out. So what about D? Even though the distance from B to C is equidistant to the distance from C to D, it is not equidistant to the distance from B to D. Thus, we cannot place a point at D. Since A and D were the only two possibilities, it is not possible for three equidistant points to lie on a straight line. So let's go back to our drawing with the circles. The two places where the two circles intersect are the only places where the third point can be placed where all points are equidistant. So right here and right here. However, as we can see, they do not lie on the same line. So what can we do in this case? We can add a dimension, essentially extending the line into a plane. I'm going to draw a box to represent the plane. So what does this mean? We need two dimensions to have three equidistant points. In other words, it is possible for three equidistant points to lie on a plane. Can we go even further? Let's try. So now I ask you, is it possible for 4 equidistant points to lie on a plane? Before we had 3 equidistant points on a plane, so let me draw it out. So we have an equilateral triangle here, and this time we need to draw spheres instead of circles, but that is hard to do on this whiteboard, so we're going to have to do a top view. So on the right, I'm going to draw the same thing, but a front view. There are only 2 places where the 3 spheres intersect, which are where a 4th equidistant point can be placed. So right here and right here. A 3D model of this can be seen at the end of this video. So I'm going to remove the circles now so you can see the points clearer. So remember, the first 3 equidistant points lie on a plane. These other 2 points do not lie on the same plane. Therefore, it is not possible for 4 equidistant points to lie on a plane. But what can we do? Add another dimension. Extend the plane into a hyperplane. I will draw a box to represent the hyperplane. So again, what does this mean? We need 3 dimensions to have 4 equidistant points. In other words, it is possible for 4 equidistant points to lie on a hyperplane. Can we go even further? Is it possible for 5 equidistant points to lie on a hyperplane? I'll leave that for you to try out, and I'll leave you with a final question. What happens when we keep adding equidistant points? I hope you enjoyed the video, and thanks for watching.